other people, and to start at least a short discussion. Would we like to go towards a common database for monitoring data? What could be the possibilities that we see in sharing data for the future, exchanging algorithms and exchanging data to focus maybe more on constrained interpretation of the data, because in many cases we saw inversion results and still the really good interpretation of other methodologies is a little bit lacking in my point of view. So to start, to give you some ideas, I would like to introduce to you now Viktoria Haider from the Geological Survey of Austria, and she will give you some ideas what we are going to do here in Austria about data and data repository. Welcome, Viktoria.
Hello, it is a pleasure that I can give you the advantage of research data repository. My name is Vicky Haider. I am working in the Department of Geoinformation, and my main focus at the moment lies on the hot topic research data management. I start this presentation with a case study. We had already a lot of case studies. I add a new case study now. I will deal with geoelectrical monitoring data there. And I give you an example of an already well-established research data repository. Afterwards, I talk about the project, the GBA research data repository, and last but not least, you will get a take-home message. I will start with a geoelectrical monitoring dataset. Here you can see a typical folder. We have a lot of subfolders there. In our case, we have 30 subfolders containing about 12,000 files, and the size is about 4 bytes. Well, if you look inside this folder, then you will find a lot of different kinds of data. You will find tables, you will find diagrams, graphics, photographs, you will find doc files, and a lot of numbers. So some of these data are already published in form of articles, and even from this dataset exists a master thesis. So the research community already knows about this data, so the data exists. But still, this dataset is stored locally. So it means, well, nobody has access to it. It is not open accessible, or it's not searchable. And if you store it locally on a server or on a personal computer, it's quite risky to lose the data. So you don't have a guarantee for a long-term storage, and it's quite difficult to reuse this data. Either your PC breaks down, so you lose the data, or you just the license of your software expires and you can't open the data. It might be possible that the software has a backup, and after a new version you can't open the data, so it's quite risky. But at least you can delete it or modify it, that's fine. But it doesn't mean that the data are sustainable. And of course, you wouldn't have a clear data policy on a local store. You wouldn't use standardized metadata, and you definitely wouldn't use a persistent interoperable identifier. So altogether it means the data are uncitable. If you put the dataset on a reliable data repository, then you can see everywhere we have green lights, except you aren't allowed to delete the data, and you are definitely not allowed to modify the data. In this case, it's good, because it means you can cite the data. But before you can put this data on a data repository, you have to make sure that you use sustainable file extensions. It means file extension which can be open even in 10 years. And it means those are file extensions, they are resolvable with open software, they are backward compatible, they can be used or loadable, it should be loadable with 32 or 65-bit platforms, and of course they have to use open standards. So for example, if you want to save vector files, then you have to save it as SVG instead of AI, AIT or CDR. AI is the file extension of the Adobe Illustrator, CDR is the extension of the CorelDRAW. So, well, after we solve this problem with the file extension, so we make sure that in this data set we only have suitable file extensions. We have to write a proper and a comprehensible data description. We put together the data, we zip the data description and the data set, we zip it. Now the data would be ready for archiving. Next step would be, we can put it in the research data repository. So it means, it means that the zip file will bound to an interoperable persistent identifier. It can be a DOI, a PURL, or a URI. And it means that you have ID to this data file, or to this zip file. To make this data findable, you would need to write or use metadata. So you have to describe the data, you have to give a title to define who was the creator of the data, define the language, give keywords and so on. Ideally, you would use a standard, a metadata standard, in this case, for example, double-core. So now the researcher can find your data, but the researcher doesn't know what he's allowed to do with the data. So it means we need a license. To say that researcher, for example, he's allowed to read it only, or he can do everything with the data as long as he decides to it. And if you already have text publication related to the data, or web applications or related other data set, then you can add links to this ID. This is what a data repository is able to do. But the data repository is not only interesting for the user, for the researcher to get the information, it's also interesting for the publisher. So if a publisher gets a new article, then he can put ID from the dataset, related dataset, on his landing page, and there's a link between the dataset and the text publication afterwards. And the published research data are also interested for research data infrastructure, for example, like the European Geological Data Infrastructure. You would harvest the metadata from all available research data repository, and to gain or to put all the information around the world, or in this case around all Europe together, to make the data findable, to use it together. Well, I want to give you an example of an already well-established research data repository. This is a website from the Pangea. This is a research data repository from Germany. You don't need to be able to read the next slides. I just want to show how the web page looks like. As you can see, the Pangea archives and publish datasets related to Earth and environmental science, and Pangea has 15 different main topics. One topic is also geophysics. For example, here on the topic geophysics, about 3,000 datasets already published. This is an example of a landing page from the Pangea. From one dataset, you can see all the metadata. You have here the contributor, the age of publication, a title. You have even ID here. In this case, we have a DOI, and you have a lot of other information to find and to find the data and to see which kind of data it is. And if you scroll further down, you get some more meta information, like they explain the use parameters, license. In this case, it's a Creative Commons Attribution 3.0 unported license. It means you are allowed to do with the data everything, as long as you cite it. And on the bottom, you can download all the datasets they are provided from this data publication. In this research, they collected data from 8 transactions and used different methods for each method, and for each transaction you get a single zip file. So you can download all the zip files, and you also get images, in this case as a PDF file, and yeah, you're allowed to use the data and you can reuse the data. So, now we know what is a research data repository and what's the approach of research data repository. And at the Geological Survey of Austria, we don't only deal with geophysical data, but also with data from basic geology, from geochemistry, water, and so on and so on. And in each discipline, we deal with points, lines, polygons, we deal with measurements, models, interpreted data, 2Ds, 3Ds. And we have a national mission. It means we have to archive geological data sustainable. And international, there's also a mission. We have to provide open access to geological research data. So that means for us that we want to establish a research data repository, a GBA own research data repository. The project starts right now. So we want to select the asset management system, install it, configure it until next June. And then we want to test this system, this data repository. During the test phase, we already publish potential research data sets, and in July 2019 we would like to launch the data repository. But that's not all what we want. We want to gain the certificate for being a reliable and a trusted data repository. So you have the possibility to certificate the research data repository. And afterwards, we want to apply for the allocation of the DOI to guarantee a sustainable and available data publication. And if we fulfill all these tasks, then we want to open the research data repository for all interested researchers with potential, for GBA potentially interested data, so that we can archive external data and publish them in the research data repository. So, some points or some message I will give you at the end. The first message is: research data repository provides a sustainable and reliable archiving of valuable datasets. Due to the adapting of metadata standards, the datasets are findable and searchable. We use published datasets they have to be cited. So as soon as another researcher uses your data, then he has to cite the data, similar to text publication. And it means that the data get a greater impact for the researcher. And last but not least, research data repository is more than just sharing valuable data. Thank you very much.
Thank you very much. I have another presentation now, and I think we will go into the discussion just after the next presentation. Thank you very much, Vicky. I know, I'm fully aware that data is the big treasure of everyone. It's a fact, but as we've worked a long time on data generation, we are now asking ourselves, if it's really our final goal to collect as much data as possible on a local side, and to be the one being in the possession of the greatest data quantity, or should it be the final goal to make as many people working with your data? If you have very high resolution data, and we are producing more and more data, and I think not even any organization has the full potential to explore all what is inside the data. For example, if you have a data repository, means once a monitoring project is finalized, we zip the data, put it to the repository, and everyone, or just combined with a certain license, can download the data and work. Means basically, for example, if Panos is working on temperature correction, and he knows that there is some data available in Austria, in Germany, in Korea, and he needs some high resolution data set, he cannot just rely on his own data. He could take data from different companies, from different research organizations, and make his student work on this data. And I definitely think the impact would be greater, and we would receive finally more reliable results if it could work in such a way. I know it's somehow a vision, and the Geological Survey we favorize the idea of a data repository compared to establishing something like a European-wide database where all the data is put to, because I think it's an illusion. It will never work. It's a data with a lot of work, and finally I don't think it will really work. But data repositories could be a way forward. But at the moment there are quite a lot of data repositories, so I think it's not a way to go if there's a data repository and some monitoring data is there, some there, some there, some there. You know, there are the European Geological Surveys, and they have one group that is called Earth Observation. I need to open the next presentation. I'm not sure if everyone is aware about Eurogeo Surveys. Eurogeo Surveys is an organization that consists of all the European, most of the European geological surveys, and they have this working group, Earth Observation and Geohazard Expert Group. And Gerardo Herrera is the chairman of this working group. And he was supposed to give this talk, but he is now in Ethiopia on field work, so I will give this talk instead of him. Well, Eurogeo Survey means that we can cover with one organization quite a large area of Europe. There are 37 geological surveys included, and they all work together in several working groups, like you can see here, on different topics: spatial information, mineral resources, marine geology, geoenergy, water resources, international cooperation, and Earth observation and geohazards. And especially Gerardo is from this Earth observation working group. And Earth observation does not only mean remote sensing, it also means ground monitoring data. So the idea that developed in the last meetings is usually people are very keen on the data, and especially in monitoring it's very difficult to put the data to some international data repository. And if you do this, it must be sustainable. There must be an organization that guarantees that data is available for a very long time. But for example, in Austria, we are working with the Torrent and Avalanche Control. They are responsible for landslides, and also with some authorities responsible for dam sites. And they don't like it if the data is kept somewhere in a different country. So it's something they don't feel well. But they would feel well if the data is kept in a repository that is elaborated at the National Geological Survey. So the idea that we might propose is that the Geological Services Europe, in terms of this working group, they can generate a network of data repositories for monitoring data. So in each of the states, European-wide, this working group is operating this data repository with the national data. And then, over a common platform, we can connect these different repositories to make data accessible and to provide a kind of toolbox to the community of monitoring people, geological monitoring people, to have access to all kinds of different data and to share data internationally. Maybe to start on a European platform first and then maybe to spread also internationally. So I'm not saying that we have to do this, it's just some ideas that we have generated over the last year, and there are some people who would like to favor this idea of European-wide databases and exchange of data. So, to conclude, after all this, I would like to start now a short discussion. If you think that such an idea could be valuable, there are some things that are against it. So I will just, for me it would be important to see what people think about such ideas. Would they be open to give the data to some repositories? Would they like the idea, for example, universities to receive data from different national repositories? And would this really lead to more international cooperation, to more exchange of ideas, and to a better interpretation of data finally? So, I'm stopping now with this, my explanations and my ideas, and would kindly ask you to comment on such ideas, if there are any. I also ask that to the data repository and things like that.
It sounds like a very good idea to me. I mean, all this valuable data that will otherwise sit in your drawers and eventually get lost, I think it really would be a shame, and it's a very good idea to make it available on long term and public in a systematic way like this. I was wondering also how have you considered something more about interchange of data formats? You are using your own data formats, I suppose. Would you keep it in that format, or would you try to translate or transfer the data to some commonly agreed data format? I know that in Denmark, for example, they've been working a lot with developing a national geophysical database, the GERDA database, in connection with their national groundwater mapping program where ERT is part, and so they have an established format, at least for sort of one-time slice of data. I'm not sure if they have implemented any sort of monitoring standard format in that database concept. But yeah, so have you thought further about the formats and how to go about with that?
Yeah, of course, I've thought about that, but at the moment, what we're doing at the moment is to save the data as it is, because it's quicker and we need to save data. Of course, it will be we need to have a kind of working group, maybe also inside of this working group, to define a common monitoring data format. This would be a very high impact, and of course, it would be the best if we can arrive here. If there is a lot of agreement, then we can try to establish also out of this GELMON conference a kind of working group, define a common standard. If many people think this is a good idea, then it would be a very nice step forward to define standards for this monitoring data format.
Yeah, this with standard formats is something that many of us have been talking about every now and then through many years, but we haven't really arrived at doing something, but it's becoming sort of more and more motivated, I think, to do something. So yeah,
I really think it could be the starting point of such a procedure in this working group. We are doing GELMON now since 8 years. Maybe we can do something more in the near future. To make a kind of working group of standard exchange formats could be a nice idea. I think maybe we could spread also a kind of questionnaire afterwards to the people who would be interested and so on. But I think it's a very good idea that we could do something more, not just meeting every second year. It's worth meeting every second year, but maybe we can do something more.
So, but that would be the question concerning a data repository. Isn't it part of data repository to find a common standard for data files, for data extension, data files extension?
Yeah. For your the aim is, of course, to standardize the archiving and publishing the datasets. It means during the project, the GBA project, we also look at this point and figure out which kind of standards we can use and how to archive the data. It's also depending on what's the aim, or what's the most interesting part for the researcher.
And even if you have different data repositories all over Europe, I think there are also tools to get data transformation, for example. So maybe this is a kind of future, even if we have different data repositories with different data standards. Maybe everybody has some kind of tool like FMA or something like that to get a data transformation, so you can exchange and make data interoperable. Even
that's a quite big challenge. But I think that the first level should be that we use the same metadata. So we use a metadata standard that, for example, data infrastructures can harvest the metadata from all data repositories and can compare the data, or can at least compare the metadata. And then the next step would be, if, for example, there are potential interesting data which should be merged together, then of course we have to establish standards.
Thank you.
I think there are these two ways that you can follow. Just save the information on the data format in the repository and make a transformation algorithm. The better way, I think, would be to define a common data format. And if how can you proceed when you define a common data format? It means that all the companies producing inversion algorithms should follow more or less this format. And I think this is the strength of this working group, because we have almost all the people inside who are producing algorithms. The Koreans, it's Loke, it's Thomas Günther, so also AGI, Earth Imager. So I think we have the potential to persuade people that produce an immersion algorithm to include also a new data format to their program. So the way is open. It's just a question, do we want to do this? It's a big challenge, and do we want to form a kind of working group on this?
So I think this is really good. And one of the things I want to mention, I've been involved in the US in several efforts relating to this thing under ERCube funding, and I think this is great. It's also, you're going to open an incredible can of worms. One of those is, for instance, storing a monitoring data set with one DOI. You're collecting a new data set every week or every month. Do you, the standard of how you deal with that is not defined right now. I mean, do you get a new DOI every month, or do you add to that? And then if you quote a data set, what do you quote there? So that's actually one open issue. Another one is that as you allude to, there's also other data sets which are important to have. So for instance, the example of, say, monitoring temperature data. Say somebody gets temperature data, and okay, you get a file which is temperature. Well, what temperature? How is the units of the temperature? The Americans, of course, have their own very funny units over there. Even like things like elevation or coordinate systems. So I would say, I think this is a great effort. I think one of the things which I would urge, and I think we should have a working group, is let's initially focus on the core data set we have ourselves. I think defining a common vocabulary rather than a common data format which expresses the transformation of the observed data into something else is a worldwide standard. Say, hey, the data collected by each of these instruments over there, we can say that maps to common parameters, so now we can go to that common format. So I think that may be the first step. And then the second step would be to set up maybe like a format for data repository where you can store the data. I think even if you can get to that point where you say, here's my data set, here's the metadata, how it was collected, which instrument, which version of the software, which current injection, those kind of things, all that metadata, which right now we don't necessarily describe in check provenance, which make the data valuable. So somebody can say, hey, I want to look for instruments where the whatever, between 50 and 200 volts or something along those lines over there, and people can search that data. So I would say, I think it's a great initiative. I think if we can resolve within this community the problem of completely describing electrical geophysical data sets, we'll have made a huge contribution, and then we can leverage efforts by other groups there about ontology of auxiliary data set and storage. So I think it's a great initiative, but I also think that if we can purely describe electrical geophysical data more completely, we'll have made a great contribution and we can leverage other people.
Okay, thank you. Our approach at the moment is that we make a repository just when we finish a test site. So we have been monitoring for, let's say, 10 years. Once we finish it, all the data, including temperature data, is put to the repository and saved there. And with all the explanations, it's once someone needs this data, it just goes there and grabs the whole bunch of data. But that's the version that we have at the moment. I think there are still many more things to do.
Can I say something, please? Of course, you're right. It doesn't make any sense if you just put all the data sets into the data repository, because the most important point is that the data has to be used afterwards. So it doesn't make sense to put data inside. Nobody would use. And so the main focus should be that before we archive or publish data, to ask, are they valuable, are they potential useful data? Otherwise it doesn't make sense to publish them.
Going back to this data, unified data format, if there is such a thing that can be done, and also thinking that this is very relevant to what Max was presented as an attempt to, we have about 10 or 20 instruments with totally different outputs, and then 10 inversion possible software that require different inputs, and of course maybe you are doing something which will be very important for everyone, but certainly there is a scope, especially for both individual and time-lapse CRT data, to adopt a kind of unified way of presenting that. And of course, one of the problems that even if a committee here decides that this is a very good format, is how we may transfer this to, and somehow this would be adopted by both hardware manufacturers and software companies. So one proposal would be, even if a committee, because here there are experts that can support this and get the knowledge, even if committees within the GELMON, and since Oliver is here, for example, one of the proposals would be, why not getting, oh, this could be done under the auspices or something, or an organization that could somehow, such as the Near Surface Geophysical Society, or so as to get a better kind of advertisement, or give somehow better value of what this could come, and get better chances that this could be adopted, if of course it's working. So this is another proposal, as if a bigger organization than GELMON, which is not a kind of an official organization, is something we are doing this the last, you are doing, and we are all doing the last years. But one of the questions is, even if we decide as a committee here, or some people working group, if this is the format, how this could be conveyed to both manufacturers and software. So this is one of the ideas that could be
What do you think,
possible.
Oliver?
Yeah, I mean, Panos is quite right. I mean, in fact, at EAG, we've already sort of been thinking along similar lines. So your standardization is certainly something that, you know, EAG would be interested in, and we haven't sort of formed an official committee yet. That would be something that, you know, I'm sure will find support. But just coming back to the, you know, I suppose almost how do you incentivize people to actually do this? Because I can quite clearly see the value for the end user. You know, once the repository is there, you know, there's obviously value in reusing those data. How do you incentivize people to actually condition their data and upload them to the repository in the first place? And I think that would probably have to be done via, I don't know, perhaps via the research funders. You probably have to work with the funders to perhaps make it almost to encourage, or almost to make it mandatory to, you know, to archive data in that way. I think without something like that, you know, it's really difficult to incentivize people to actually do that, because, you know, on an individual project level, you know, at the moment, I'm guessing not very many people have sort of written that into their project plans or into their PhDs or into their organizational strategies. I mean, maybe on a local level, but, you know, what I'm saying is there's extra effort involved, and there is a sort of a possible reward at the end, but you somehow need to incentivize people to do that. And I don't know whether anyone's got any thoughts on that.
In the United States, both the National Science Foundation and Department of Energy require, as of a few years ago, that when you publish the data, you publish a paper, that you make the underlying data available in a digital readable format. And it's something that has not been enforced a lot, but basically the message I've gotten from funding agencies is that they will now, at the next review period of several projects, use it as a hard criterion whether you continue funding or not. And the program managers are aware of it. So this is basically something that has a high priority, where people say, look, if you cannot show that your data is available, we will stop funding. And that's, you know,
I think you need that.
yeah, and so the problem that people have is they don't have the tools. So I think if you made a tool available, say, here's a repository for electrical geophysical data where you can upload your data, a lot of people will be very, very happy, because they can point to, okay, I'm going to put it in the GELMON repository. You know, so I would say, at least in the US, that carrot and stick are there. You know, I'm not sure about Europe.
I also in Austria, it's now, if you apply to the Science Foundation, you need to provide a data management plan stating a certain repository where you will put the data finally. If not, then you will not receive anything.
Well, we have the same in the UK, but I mean, on a practical level, I'm not sure how well that's kind of policed and enforced, if you like. So I don't know, that might be different elsewhere.
I think maybe people are a little bit aware of putting their data, their treasure to the repositories, but maybe it's easier if you come over Future Service and the National Geological Services, that they are responsible and they do the organization in each of the countries. So if there's a common focal point in each of the countries, they might prefer to put it there and make it available. And if they have some impact on the geological service, we have a good cooperation with all the universities and we know who is doing what in Austria. So we can encourage them to put the data there, but we can also tell them, yeah, if you put your data there, you can also receive data afterwards. And I think the biggest problem, at least in Austrian universities, is that they don't have data because data is very expensive. Especially long-term monitoring is very expensive and it's not funded at universities. If you have a research project, it's 3 years, and usually they don't take long-term monitoring data, what you in many cases need. There could be a way to, not only to force them, but to attract them, because if they send data, they will also get something. They can get other data. And so I think it could work in some environment like this, not just forcing them, but also attracting them. Some more comments?
Maybe just a comment from someone who finds himself more and more going onto these repositories and trying to actually download data. The example from seismics maybe is a good example. I think the standardization is a very important factor, but you're going to have two challenges. One is going to be retroactive. The data that you've already collected, how does that then get involved? So even if you manage to convince the few manufacturers to put this as a standardization, you still have all the work that's been done up till now. You could think about a third in-between kind of container with this idea of the file header, where you could have all the metadata inside, which would give the information about the instrument, the type of data, when it was collected, and then just the data set, which could be then extracted separately. So for example, in the seismic data, the mini-seed and the seed are very well documented online. So even though I have not studied seismology, I can go onto the mini-seed, understand how it works, write a small piece of code that would be able to extract the data that I need. So in terms of once you have the repository, I mean, you're all talking about it as a kind of research community, but there are other communities that would also be interested in accessing the data, and it would be really interesting in this standardized version of the container to have some sort of documentation that would explain how the logic of the architecture of the container is set up. And that would really make this data interesting also for things that are maybe not anticipated by the research group that's dealing with the original data set.
Some more ideas, some comments? I would really be happy if somehow we can define now in this meeting that maybe we have the goal that at the next German conference we will have a standard format for monitoring data. Not depending on who is really organizing that, but from this group to impact other people, maybe the surface, to set up a kind of working group to define this exchange format for geoelectrical. Let's start with geoelectrical monitoring.